Greetings, Prezzo here. Thanks for dropping by. I've got a new sticker to put up on the door, so let's get it up there and have a look. Now I had to ask the owner of this channel, Michelle, how he came up with his name, Rust Inox. Now he was kind enough to explain it to me. In his country, stainless steel is known as inoxidable, and rust is the opposite of that. So it's just his little play on words, or a bit of a tautology. But Michelle runs a home workshop and he does pretty much what I do. So if you like what you see here, you're going to like his channel as well. Now he does do a number of skill building tutorials, which are excellent. He does a bit of model engineering and just general shop work, so it's well worth checking out. Now, the most interesting thing is that Michelle comes from Belgium. Now, Belgium is that wonderful country where they do beer, chocolate, French fries, and some stunning architecture. Ah yes, Belgium. Love to visit there one day. Oh, chocolate, French fries, beer. Oh yeah, sorry, forgot. Fortress Australia. We won't be leaving here anytime soon. Now, what's today's video about? Well, get your fireproof panties on and meet me over the bench. We're going to do some metal casting. Now, this is what we need to do today. So I need to be able to make 10 of these parts as castings and then machine them until they look like this. And these parts are going to fit into the tops of these fabricated garden lights that I've been building. Now, I've done 2 videos on this process already, and you can check the links at the top of the screen there, or check the playlist, and that will take you to the first couple of videos, which are all about fabricating these aluminium structures for the garden lights. And I've decided to do these castings, although you could fabricate these from solid stock. You could make them out of some sort of a polymer, or you could just 3D print them if you wanted to do it that way. But just for the fun of it, I want to do them as castings, and I'm going to use a slightly different method than I would normally do for doing these, because I need to make 10. And making 10 individual molds is just too time consuming. So let's have a look at the process that I have in mind. Okay, this is what I have in mind. Now this is called a pattern plate or a match plate. Also, just to be confusing, sometimes also called a plate pattern. And the way this works is it allows you to fit individual patterns onto a board. You can have as many as you like, I guess, up to a certain point. And in the center of that, there's a 3D printed set of gates and runners. And my sprue is going to fit into that central hole there. So the metal will enter through the sprue, it'll fan out through these 4 gates and into the cavities left by these halves of the pattern. Now on the other side there will be a second part of the pattern, and what we need to do is get these aligned with the top part here. So remember, on the finished part there's a decorative top, and then underneath that there's a piece like a socket that has to fit inside the square aluminium tubing. Now you could make like split patterns and do them in the traditional way, but because I've got to do 10 of them, it's going to get quite time consuming. So this is a much more efficient way of doing it. Now with these 3D printed holes in here, I've just got to drill through the MDF plate. And then when we turn that over here, you can see where the holes have penetrated through there, and we can just simply put the other half of the pattern into those holes. Now I don't have to deburr all of that, but you got the idea there. So eventually, come on, there it is. So eventually the other 2 of these will be arranged like that, and they should align perfectly with the parts of the pattern on the top of the match plate. So these will form their own individual cavities underneath, and then on top in the cope we're going to have all of this arrangement here, which will fill with metal. So that's the plan, and this will have to be primed and painted and fill all the layer lines in the plastic and so on. Now I'm going to use these parts later after we've got everything assembled. I'm going to add these on top. I'll just use some cyanoacrylate to attach those. And these are going to form like a blind riser. I think that's the correct term for it. And this is partly to allow some liquid metal to replace what is going to shrink on our finished patterns here. And it means I can cut those parts off and machine them flat later. And if I get any localized shrinkage on top of that riser, it doesn't matter, it's scrap anyway. Now, normally a riser, and there's debate about what you call them, but that's what I call them, it would penetrate right through to the top of the cope and would be open. Now, for various reasons, I'm not going to do it that way, and I'll discuss that as I go ahead and make the mould. But what I'll do now is get these parts fitted, and then we'll get everything prepped, and we'll have a look at the mould making process. Simple. I've just gone ahead and finished that up now, and this will require some filling and painting and so on. We do need to waterproof this MDF plate as well, but essentially that's what it's going to look like when it's put into the flask. So my sprue will go down through that central hole there, and then these gates are going to distribute the metal into the 4 cavities. Now remember, the finished part looks like that. So these blind risers will get cut off and machined flat like this one here. And also these patterns are slightly oversized to allow for shrinkage and also some machining allowance. So they will look a little bit different to this one, which is a representation of the finished part. Now if I turn that over, you can see that I've got my 4 bottom halves of the pattern assembled there now. All of these patterns have got draft on them, so that we can remove them from the molds easily. Now the procedure for making a mould with a match plate or a pattern plate is a bit like making a single casting from split pattern. The only difference is that when I ram up the drag, I'll already have the match plate attached to the cope. So this is going to be the top of the flask when we're done. So I can align my match plate with the pins. I can put the drag on top, and this way I can ensure that everything is aligned. So I'm going to ram up the drag first, strike it off, put a board on that, flip the whole thing over, and then we can ram up the cope. We can make sure we've got our sprue in there, get all of that prepped, and then before we dismantle anything, we can just go around and tap the edge of the match plate, and that's going to vibrate everything inside there and hopefully loosen everything up so the cope and the drag will come off clean. Alright, that's the plan. Now at this stage it's all theoretical. I've never done this before. Read about it, I've seen it done by other people, but I haven't had a go myself. But you know what? It seems like a logical way of doing it, so that's a good place to start, isn't it? Anyway, let me get this all prepped and painted and everything. Will come back when we're ready to start making the molds. This is where I got to yesterday. So this had a couple of coats of automotive acrylic paint, top and bottom, and that's going to help to seal the MDF, but also to give us a sort of a smooth coating on these 3D printed patterns so they'll release more easily. So I'm going to go ahead now and get this one rammed up. This is the first one I've done. I haven't had a practice at this, so anything could happen. But yeah, let's give it a go. This is calcium carbonate, or basically chalk dust. And you really don't want a thick layer on there like what I have, but the idea is to try and get the chalk dust to adhere to the coating, in this case that red paint, and it just forms a sort of a release layer. Most of it's going to come off. Now you might notice I've added a new end on my ramming tool. Now this is just a block of aluminium, and I realised after making this ramming tool that the end that I had on here, the wedge end, was way too small in cross section. The wedge was much too fine a point, and the edge here was too sharp, and it was just penetrating through the sand. Always a danger you're going to hit the pattern and damage it. So this seems to work much better. Also, I've decided to try ramming the sand less than what I used to. I used to really go at it. The idea, I thought, was to make sure that you got really good contact with the pattern, and that would help to improve the surface finish on the casting. But the downside of that is that you make the sand so dense that there's nowhere for the air to go when you pour the liquid metal into the cavity. So it should be able to permeate through the sand, which should be porous, but I was finding it was sometimes not filling the cavity properly, and I suspect that was partly the problem. So this time I've been a little bit more gentle in ramming the sand, and we'll see if that makes a difference. One of the things I found is that if you've got a freshly painted pattern, the first time you mould from that, it tends to stick to the sand. Once you've used it a number of times, it seems to be fine, but the trouble is hardly ever use the same pattern twice. So I'm just going to put a light sprinkling of that parting powder on the actual board itself rather than on the pattern. And I've moulded this sand so it's fairly dry. You see it's falling through that sieve quite easily. There's quite a lot of detail in this centre part here, which is why I'm using my fingers to try and press the sand into those detail areas, because normally you'd cut the runners and the gates later in the compacted sand, but in this case you've got to rely on the imprint that we get straight out of the sand. So before I take that sprue piece out of there, I'm going to cut my pouring basin. Alright, now this is where it all goes pear-shaped. So what we need to do is lift the cope off, and at that time we're going to be extracting the pattern from the cope. And it's quite different to how you would do it if you were to invert the cope and then extract the pattern from this surface here. So I don't know how this is going to go, and of course the pattern on the cope side has got the most detail on it. And I think the plan is you just simply wrap the actual cope itself and you can also wrap the pattern plate. Alright, I'm going to clear the decks here and we'll see how this goes. You know what? I reckon that worked. Alright, wait till I do this one and then we'll have a closer look at both halves of the mould. Now this one is a little bit more problematic because we don't have the pins to guide us to bring these up. So yeah, alright, let's just take this straight up then. And there you can see the problem. So I obviously shifted that sideways when I took it off. So maybe I need to rethink how I do these pins here. But once again, I don't think that's going to matter. The interior looks great. It's really sharp. So I'm going to clean this one out. So let me give you a close-up of this. So there's a broken area along here. That one's good, that one's good. A little bit of a broken area there. But once again, that doesn't matter because all of that's going to get machined off. But everything else there is super sharp. So maybe I've learned a new way of doing this. Maybe I was ramming too hard all along. But super happy with that one. Let's have a look at this one. The best thing is that all of this work is done. So all of the in-gates and the runners, everything all done. Don't have to worry about that. The blind risers, which are right at the very bottom of that cavity there, I'm hoping that they're going to allow the air to escape through that sand. Now, remember I didn't ram this as hard as I would normally do it, so that sand should be fairly porous and permeable. And I'm also going to put some vents in the top, but I'll carry this one over and put it near the furnace and then I'll do the vents. Actually, I should have done that first, shouldn't I? What I'm worried about is when I push the vent wire in from the other side, I might pierce that cavity and drop sand in there. So let me see. Yeah, I didn't think this through, did I? Now this may be totally unnecessary, but I was watching a video by LuckyGen1001. He was talking about vents, and he's one of these people that does a lot more reading than I do. I'm typically a suck it and see kind of foundryman. But he had mentioned the fact that if you would push that vent wire right through into the metal cavity, as soon as the metal comes to the top of the cavity, it will plug these holes formed by the vent wire. So his suggestion was that you don't push the vent wire all the way through, you just push it near the top of the cavity. So I've got a bit of tape on there, and that's going to allow me to push the wire in, but it won't penetrate all the way through into the mould cavity. But like I say, I'm a bit worried. Yeah, that's actually pushed the top of the mould in the cavity on the inside. So I'm not going to do it. I'll just I'll do this one and see how we get on. What I don't want to do is to collapse that cavity on the inside. I should have done this while I still had the pattern in there. But there you go, Mark. Not thinking ahead, are you? But let's hope this one works. Okay, I've gone ahead and I've rammed up the second mould, and the pattern is still in there. And this is what I should have done on the first one. I should have actually pushed the vent wire down before I removed the pattern. So once again, this is the depth I can go to without breaking into the cavity in the cope. And I'm just going to push that wire in a few places. And this will actually give us an opportunity to see whether it makes a difference between having a vented mould and a non-vented mould. Now, the only problem is where I've got the pouring basin, there's actually a cavity directly underneath that. So I'm just sort of going to go around the edge of it really. I probably should have brought that pouring basin out on the diagonal, but then the other issue is that you want the pouring basin to be really close to the edge of the cope. So when you tip your crucible, you'll get it close to that pouring basin, and it's not like they dribble down the side there. So Bill, if you're watching, I do pay attention to your videos. Alrighty, so let's get this one separated, and then we're going to light up the furnace, and I'll cast 8 of these, and then I'm going to make up one more mould, and we'll do 4 more, and I need 10 altogether, so I'll get 2 opportunities to practice. Or if I get 2 screw-ups, it won't matter. Alright, here's a close-up of the second mould. So this is the cavity in the drag side. The edges on these cavities come out super clean and sharp. there's the cope, and the same things happen there. It's the detail in that is really good. So you know what, I've learned an important lesson. Don't ram the sand so hard, Mark. Yeah, I'd just been overdoing it, and the more things failed, the more I thought I had to ram the sand harder. And I did an experiment a while ago. I made a very, very quick casting from a fairly complicated pattern, and I just rushed one through really quickly, and it actually made a really good casting. And at that point I thought, oh, I just got lucky. But what had happened was I didn't spend a lot of time ramming the sand. I just thought I'd throw one in, and while I had some spare metal in the crucible, I thought I'd pour it, just see how it went. And it was the best one out of all the ones that I'd done. So there you go, learned a lesson today. Well, what's going to be, guys? Legend or loser? This is the first one that I did. This is one that didn't have the vents pushed through on each of the cavities. So we'll see how that goes. Drum roll, please. Come on, suspense is killing me. Alright, that side's looking good. Okay, now we got some shrinkage on top of those blind risers, but that is not a problem because they're all coming off. So there it is. Well, it seems that you don't need to ram the sand as hard as I used to, and even though I didn't have vents over each one of those cavities there, it seems to have done the trick. Anyway, let's have a look at the other one. I'm just going to mould the sand from that first mould before I open up the second one, otherwise it'll be too much in the drum here. And I've made a number of improvements to this molar. Now, Lucky Gen 1001 got in touch with me, and he told me that the best way to stop the sand sticking to the roller was to put packing tape on it. And so far that seems to be working really well. He also told me to put ball bearings in the roller, and prior to that I just had plain bearings in there, and that's made a world of difference as well. Initially I was worried that sand would get into the bearings, but he said he's had sealed ball bearings in his for years and years and never had a problem. And the other thing I did was I put a cam on the motor to keep the belt tension, and I put a new aluminium pulley on the drum. When I made this muller, I just used a temporary plywood pulley, and adding that aluminium pulley's made all the difference. So now it's working even better than it did before, and certainly saves having to get down on your hands and knees and use your hand. No one wants to do that. So this is the one that was vented. You can see little holes where I pushed the vent wire down there. Oh, again, that's looking good. Totally happy with that. Wait till I get this one washed off and I'll show you a bit more as a close-up. Here's one that I've separated from the runners and the gates and so on. And I'm absolutely happy with that. I know it's not perfect, but for what I want, it's going to work perfectly. And the definition on that edge there, that face, is as good as I would ever get using the green sand that I've got. And although there's some shrinkage on top there, that's why I put this blind riser on top of this part. So I can cut that off, machine the top, and we don't have that issue. But without that, if I hadn't put that on there, we'd have the same defect in the top of the casting itself. So I'm happy I did that. This is from the second mould, the one that I vented properly. Hasn't seemed to have made a big difference. There's probably a little bit less shrinkage on top, but I don't think that's due to venting. The other thing you would have seen me do there is I checked the temperature of the melt. That was at 720 degrees just before I turned the burner off. Now the pouring temperature for aluminium is somewhere between 650 and 700 degrees centigrade. But I figured by the time I did it around and got the dross out of the crucible, we'd be back down to the temperature that was at the upper end of pouring. And it's worked fine, so I'm totally happy with that. Now I'm going to make up one more mould. I'll make 4 more of these, and then if we got time we might quickly look at the machining. But yeah, good day so far. 100% yield rate so far, which is almost unheard of in Prezzo's foundry. There you go guys, 100% strike rate on this particular casting exercise. Never happened to me before. I've always got at least one failure, even if I only make 2 castings. So I'm super happy with this. Here's one that I've just simply cleaned up around the edge, just on the belt sander, this area here. And I've already tried this in this fabrication that I've made for these path lights. And it's very, very close to its correct size. I didn't leave a lot of machining allowance on this. And in fact, what I'm going to do is just machine these 2 surfaces here and these 2 here, so it will actually fit inside that piece of square tubing. And I'm going to leave these edges as cast. Well, this one needs cleaning up obviously, but pretty much I want to leave the casting texture on that, and then when these are powder coated, it's meant to look like a casting. So I was lucky there with the actual size, so the shrinkage has brought it in almost to the correct size without having to machine anything around this edge. Now obviously these tops are going to come off, and I'll do one of these. I'll get one of these ready and I'll show you, and that's probably the end of this video. So what did I learn today? Well, first thing is make sure that you don't overram the sand. Now that's a mistake I've been making for quite a long time, and I'm glad I've recognized what that issue was. The next thing is to make sure that you get the metal hot enough. So I took that up to 720 degrees centigrade. I think on the last one it was 740, and these have filled the molds without any issues whatsoever. The next thing is to make sure that you put that little vent wire down, but do it before you take the pattern out, and that way you're not likely to fracture anything into the mold cavity. And finally, use a match plate if you want to make more than say 1 or 2 parts. That match plate has been fantastic. I reckon that's worked brilliantly, and it would have taken me forever to do 12 of these parts as a split pattern and making them individually in their own molds. Now there is a thing called a snap flask that you can use, which is like a flask that you can dismantle and take away from the rammed sand, and that way you've got just the rammed sand sitting on a board and you can pour the mold. But I don't have enough sand to be able to make 12 individual molds, but I can do 4 at a time in that flask that I made. So there you go. I did learn something, and I think now's the time to call it quits. It's getting late in the afternoon, and when we come back in the next part of this video I will have one of these already machined. Here's just 4 of the 11 finished castings. Now I did 12 castings in total. I finished 11 to this stage here. I only need 10, so I've got 1 spare. To get them to this point I had to saw off that little blind riser, and I did that in my small bandsaw. From there the parts went across to the Bridgeport milling machine, and the top surface that was sawn was cleaned up with a small fly cutter. Now all of the parts were done at the same setting, so they should all be the same thickness. From there they went across to the small CNC milling machine, and I cleaned up the surface that fits inside square tubing. Now this was done with an 8mm roughing end mill. It was done as a roughing pass, then a finish pass, and from there all the parts went into the sandblaster. Now, I just wanted to get a rough idea of how they were going to look when they were finished, and I must say I'm really happy with the way they've turned out. Now, don't forget, they're meant to look like castings, so if you see some imperfections there, that's all part of the plan. But yeah, totally happy with the way these have turned out. Right, here's one of the light assemblies almost finished. Now, these screws that you're seeing here at the moment will be replaced with countersunk head stainless steel M3 metal thread screws, and at the bottom we're going to be using stainless steel countersunk self-tapping screws. Now, at that point, the light fitting will be removed, the light assembly at the bottom, and this top part will be sandblasted as a unit and then powder coated. And the idea there is to try to fill in all of the gaps around the joint between the cap and the body with powder coat, and it's just going to look like a finished unit. Now, hopefully I'll never have to remove this cap once it's been assembled. The glass can be slid in from underneath, as can the peg and the light fitting itself, so that whole unit will go together with just the two screws that are fitted into these holes here. So I'm going to leave this episode here now. We've done enough. In the next episode we're going to be doing the glass that goes in the front and the back of the light fitting, and I'm going to be introducing you to a YouTube channel that I found by accident, but I think you're going to enjoy it as much as I have, and it's been the inspiration for how I'm going to do the glass. So tune in for that. It's going to be a cracker. So it's Prezzo signing out for now. Thanks for hanging out in the shop here with me today, and we'll see you next time. Cheers.